Hello everyone, welcome to Ramaile Padai. Today we are going to learn concepts about construction, that is lesson 11 of class 10 mathematics, and from this chapter we will get question of about 3 marks in years AE. So let's start the conceptual video. First of all, we will learn about the types of construction. So there are basically 4 types of constructions, and they are construction of parallelograms equal in area, construction of triangles equal in area, construction of triangles and parallelograms equal in area, and construction of triangle and quadrilaterals equal in area. So all type of constructions involved equating the area, that is equal in area. We will first start with construction of parallelogram equal in area, then move on to B, C and D. But before that, let's learn or recall the concept or the theorem of triangles and quadrilaterals. That is, in theorem 1, parallelograms are equal in area if they are standing on the same base and between same parallel lines. Okay. So what I am writing standing on the same base and between same parallel line is that all the 3 theorems of triangles and quadrilaterals include this statement, that the 2 triangles or parallelograms or quadrilaterals must be standing on the same base and between same parallel lines. Okay. So in theorem 1, parallelograms are equal. In theorem 2, triangle is half the parallelogram in terms of area, and in theorem 3, the area of triangles are equal. So let's learn a bit more about theorem 2. That means area of triangle is half the area of parallelogram, or we can also say that area of parallelogram is 2 times the area of triangle. Okay. Now let's move on to first type of construction, that is construction of parallelograms equal in area. So here is the statement or question. We need to construct a parallelogram ABCD where AB is equals to 4 cm, BC is equals to 5 cm, and angle ABC is equals to 6 degrees. So for this we will first draw a straight line of AB. So this is AB. This is 4 centimeter. You draw it with scale. Okay. Now we will make an angle 60 degree at B. So this is angle 60 degree at B. So angle ABC is 60 degree. Now we have BC is equals to 5 centimeter. Okay. So we will construct. We will construct a line that is 5 centimeter long with an scale. So this is 5 centimeter long line constructed with scale. Okay. Now for parallelogram, the opposite sides must be equal and parallel. Okay. So this AD must be 5 centimeter and CD must be 4 centimeter. So first we will put compass here, and we will make it make the compass that have a radius of 5 centimeter. So we will first do this arc, and then we will construct CD with 4 centimeter. So we will point this compass here, and we will mark arc somewhere here. So this will be D. Okay. So this point is this. Okay. So this is ABCD. So this is 4 centimeter as well, and this is 5 centimeter as well. You will visualize actually and in good ways in our practice video that will come after this video. Okay. So keep looking to our channel as well. So we have constructed the parallelogram A, B, C and D. Okay. So this is the next step. How can we construct a parallelogram whose area is equal to the area of parallelogram ABCD? So we need to draw and construct a parallelogram that have equal area. Okay. So we need to construct ABPQ which have an angle 120 degree. Here our parallelogram has angle 60 degree. So we need to construct another parallelogram that have angle of 120 degree. And in second, we need to construct parallelogram ABPQ having one side 6 centimeter. Here our 2 sides are 4 centimeter and 5 centimeter. But we need to construct a parallelogram that is equal in area and have one side 6 centimeter. Okay. So what you know from theorem 1 is that if the 2 parallelograms are standing on same base and lying between same parallel lines, their area are equal. Okay. So first we will construct a parallelogram ABCD. So this is what we have constructed earlier here. Now we need to have 120 degree. Okay, so this is about first situation. Okay, so we need to have 120 degree. So first of all we will construct a base AB because they are standing on the same base AB. Here the orange means another parallelogram. Okay, so now we will construct a 120 degree in B such that this is 120 degree. Okay, so this is 120 degree. Okay, fine. Now we will extend this DC to this way and extend BQ to this way, so that these two lines meet at point Q, and this will be one vertex of one corner of parallelogram. Okay, so this is Q, this is one corner of parallelogram. Now as you know, the opposite sides of parallelogram are equal, so BQ must be equals to AP. So there here will be P. So we will first put a compass, the point of compass here and pencil here, and we will then put the tip of compass here and make an arc on this line DE. I think here will be an arc, so we will join A to this arc, so that ABQP become a parallelogram that are equal in area. So here the area of ABCD must be equal to area of ABQP. Why? Because they are standing on the same base AB and lying between same parallel lines DE and AV. So they are equal in area. Okay, and the parallelogram ABQP has 120 degree as well. Now let's move on to another situation where one side is 6 centimeter. Okay, so first we will construct this parallelogram ABCD. Now we will extend this DC up to E. Okay, why? Because we are making the parallelogram in between the two parallel lines. Okay, so here base is AB. Now what we have is one side is 6 centimeter. So you will first set up a compass to 6 centimeter radius, and then you will make arc from here. This will be the arc, and we will join the line, the point B up to this arc, so that it become BQ. So this is BQ and it is equals to 6 centimeter. As you already know what we have done in this first situation, we measured the BQ with compass and then mark it here at P. So here we also measure BQ, that is 6 centimeter, and from A we will mark at here 6 centimeter on this line DE. So it becomes AP. So here the area of ABCD and ABQP is equal. Why? Because they are standing on the same base AB and between parallel lines AB and DE. So this is about the two condition of construction of parallelogram. Okay, now let's move on. We will move on to second situation where we will construct triangles which are equal in area. So the problem is this: how can we construct a triangle which is equal in area with triangle ABC, and triangle ABC have angle ABC is equals to 60 degree, BC is equals to 4.4 centimeter, and AB is equals to 5 centimeter. So first of all we will construct AB, that is 5 centimeter in length. Now the angle ABC is 60 degree, so we will make an angle here 60 degree. Now this line, we will extend this line up to C, so that the length of BC is 4.4 centimeter. Okay, so this is 4.4 centimeter. Now we will join A and C, and here is our triangle ABC. Fine. Now in A, construct a triangle ABD having an angle 120 degree. So we must construct an angle 120 degree here. So this is triangle ABC. Now we are drawing an angle that is equal to this angle. So this angle is 60 degree, so we will also construct 60 degree here. You will learn how to construct 60 degree angle in our practice video. Okay, so keep watching the practice video as well. So why are we making this 60 degree angle? Because we will be constructing a parallel line AB and this line, so that two triangles stays between the parallel lines, because we have condition in our theorem, that in theorem 3, that is the two triangles standing on the same base and between same parallel lines are equal in area. That is theorem 3. Okay, so we are making parallel lines, and this we will extend this line so that MN parallels AB. Why? Because the two angles are alternate angles. Okay, alternate, I think it is alternate. They are equal and they make parallel. That is what I know. I might get confused about the name of the that angles. Okay, so this is parallel line. Now we will construct and base a base AB. So this is AB is base of new triangle. Now we will construct an angle 120 degree here. This is 120 degree. Now we will extend this line up to D. So BD. Now we will join A and D. So this is triangle ABD that have equal area to triangle ABC. Why? Because they are standing on the same base AB and between the parallel lines AB and MN. Okay, this is about situation 1. Now moving on to situation 2, we have triangle ABC. Fine. Now we will first construct a parallel line MN so that AB parallel MN. For that we will need to construct an angle here, this angle, and extend this line. So AB parallel MN. Fine. Now we have a side 6.2 centimeters. So we will need to make an arc from B up to this line MN such that BD becomes 6.2 centimeters. So first we will construct AB base, then BD is 6.2 centimeter. Now we will join A to D. So this ABD have area equal to ABC. Why? Because they are standing on the same base AB and between same parallel lines AB and MN. Okay, so this is about construction of triangles equal in area. Now we will move on to the third problem, that is construction of triangles and parallelograms equal in area. So now let me remind you the theorem 2. Here the area of triangle is half the area of parallelogram if they are standing on the same base and between same parallel lines, which also means that area of parallelogram is equals to 2 times the area of triangle. Okay, now let's see the problem. So construct a triangle ABC in which AB is 4 cm, BC is 6.5 cm and ABC is 120 degrees. So this is AB, this is 120 degree up to C. So we extend this line so that BC is 6.5 cm. So this is 4 cm AB, this is 6.5 cm BC. We will now join A and C so that ABC becomes triangle. Now we need to construct a parallelogram having a side PB is equals to 5 cm and equal to the area of triangle ABC. Here the triangle have base 4 cm. Now if we need to make an area and parallelogram that is equal in area, then we need to cut the base to half, because the formula of area of triangle is equals to base times height, half base into height, and the area of parallelogram is equals to base into height. Okay, so we need to make the base half so that of the parallelogram so that the area becomes equal. So first of all we will need to construct an angle here so that we can construct a parallel line AB and MN. So these are parallel lines. Fine. Now what we will do is construct a base of the parallelogram that is half the length of AB, that is 2 cm. So DB is equals to 2 cm. Okay. Now we have PB is equals to 5 cm. So here somewhere here there will be P. So PB needs to be 5 cm. So we will construct we will first measure the 5 cm with a compass, and then we will point the compass, one end of compass here at B and another end making arc at line MN so that it becomes PB. So which is 5 centimeter. Again from D we will make an arc of 5 centimeter to MN. So this DBPQ is a parallelogram that have area equal to triangle ABC. So area of DBPQ is equals to area of ABC. Okay. So this is about this situation, question 1 or problem 1. Now moving on to problem 2. Construct a parallelogram ABCD in which AB is equals to 5 centimeter, BC is equals to 4 centimeter, and angle ABC is 6 degrees. So we will first construct parallelogram. Here AB is equals to 5 centimeter, so AB is equals to 5 centimeter. Now we will construct ABC is 6 degrees, so this angle is 60 degree. Now the length of BC is 4 centimeter, so this is 4 centimeter. Now we will make an arc from A for 4 centimeter from A and 5 centimeter from C, and the point that meets at where two arc meet is point D, and this is parallelogram. Fine. Now we need to make a triangle so that the area become equal. Okay. How can construct a triangle PB with side PB and equal area to the parallelogram? So we need to have a side PB 6 centimeter and area equal to the area of parallelogram ABCD. So if we need to make an area of triangle equal to area of parallelogram, then we need to double the base. Okay. But first we will construct extend the line DC so that to MN, so that we can visualize that MN is parallel to AB. Now we will extend AB, we will make the base of triangle double the length of AB. So BE will be the length of triangle, that is 10 centimeter. Okay. Now we will construct a PB, that is 6 centimeter. So from this point B we will make an arc of 6 centimeter to the line MN so that we meet P. So this PB is equals to 6 centimeter. Now we will join E and P. Okay. So here area of triangle EBP or PBE, we can write PBE is equals to area of parallelogram ABCD. So this is about construction of triangles and parallelograms equal in area. Okay. Now let's move on to last problem, that is construction of triangles and quadrilaterals equally. No, this is the third problem. Okay. We will have another problem at the last. So construction of triangles and quadrilaterals equal in area. So here we need to construct a quadrilateral PQRS where PQ is 5, PS 4, QR 4.4, RS 3.6 and diagonal PR 6.4. This will be like this PQRS. So this will be the quadrilateral. Okay. Now we need to construct a triangle PSG whose area is equal to quadrilateral PQRS. So first of all we need to find write that this is D, okay, not C, and we will first construct quadrilateral PQRS. So this is PQ, that is 5 centimeter. Here the diagonal PR is given. Okay. So first we will construct PR. Okay. So here there will be R and there will be S. So we will make an arc of 6.4 centimeter from P to R, and we will also make an arc of Q to R, that is 4.4 centimeter, like this. Okay. So this will be arc. This point will be here. This is how we first make a triangle. Now we will make an arc of PS, how much, 4 centimeter, that is P to S 4 centimeter arc, and R to S, that is 3.6 centimeter arc, and here it will be PQRS. Okay, this is quadrilateral. Now we need to construct a triangle P, S and G somewhere here, so that area of quadrilateral is equal to area of triangle. So first of all we will construct a diagonal QS. So this is diagonal QS. Now we will make a parallel line RS, that is parallel to SQ. So we will make this angle equal and extend this line from R to H. Okay. So these two lines are parallel with each other. Fine. Now we will extend PQ to this areas at G. So this will be the base of triangle. Then we will join S and G, and then we will join PS. So this triangle PSG have area equal to quadrilateral PQRS. How? Let me explain you. The area of triangle SQG is equals to area of triangle SQR. Why? Because they are standing on the same base SQ, and between parallel lines SQ parallel RS. This is according to theorem 3. Okay. Now if we add area of triangle PQS on both sides, then we will have SQG plus PQS, that is PSG, and SQR plus PQS is equals to PQRS. So this is how the area of the triangle and quadrilateral are equal. So this is about the last problem or last situation of this concept video. We will meet you in the next video. If you have any confusion, please let me know in the comment section down below, and we will see you in the next video. Till then, bye bye.